Hello, my name is Iannetta. I am a research scientist based at the James Hutton Institute. My specialist area is legume crop science. And here today I'll give you just the very briefest of introductions to the science which underpins the NCS project. The James Hutton Institute leads Work Package 1, which is focused on environmental, climate and socioeconomic impact evaluation of crop rotations which are grain legume based. With the other science leaders, the Institute is also heavily involved in Work Package 3, that is the experimental platforms. These experimental platforms include those which are based in field but also in controlled environments. It should also be understood that the science-based efforts of the partners is undertaken across all the work packages, but here I'm talking mainly with respect to Work Packages 1 and 3. The James Hutton Institute will be developing a tool for life cycle assessment, or LCA for short, of crop rotations. This will complement and add value to the farm level accounting tools such as the Farm Carbon Toolkit. The LCA tool will be developed using data from the Centre for Sustainable Cropping. This is a long-term crop rotation platform which tests integrated farming approaches and offers an unparalleled data set. This will allow an assessment of system functions as well as system impacts. These functions relate to aspects such as biodiversity, plus water and soil qualities. Data from the Centre for Sustainable Cropping will be allied to data from other platforms. This will include data from PGRO's experimental platform Stubton, whose annual grain legume trial area forms an integral part of the farm's overall crop rotation. It should also be highlighted that data from farmers themselves will also help direct development of the life cycle assessment tool, but also the Farm Carbon Toolkit too. As well as historic data from the field-based experimental platforms, there will be direct measurements of greenhouse gas production. This effort will also be supported by the Game and Wildlife Conservation Trust. Research will also see direct measures of biological nitrogen fixation by legumes and better quantification of the contribution from legume crop residues. And that contribution will be assessed both in terms of the nitrogen offset or nitrogen fertilizer offset, as well as direct carbon contribution. As you might imagine, soft structural and functional attributes will be a special focus for more detailed measures. This interest will extend to soil nutrient status and aspects of biodiversity such as earthworm counts. In addition to the life cycle assessment of crop rotations, the science data will also inform the development of other new tools. Here, the model tool Goblin. Originally developed in Ireland for national greenhouse gas accounting of Ireland's livestock industry, it will be adapted to create a new crop rotation assessment tool, a tool we currently refer to as Crop Goblin. The Goblin model takes what is known as a backcasting approach. That is, it considers a desired future as the starting point, and then it works backwards to identify the types of crop rotations or crop rotation scenarios which will achieve that future. The crop rotation scenarios assessed by Goblin will provide an environmental impact assessment at large scales of uptake. And here I am referring to scales such as those of the catchment, region, and nationally. I'll not say too much about the Farm Carbon Toolkit, as I know its role is being explained in detail by another project partner. Nevertheless, it is worth highlighting briefly that the science data gathered in Work Packages 1 and 3 will feed towards developing the toolkit and facilitating a more accurate and nuanced assessment of the field and farm level activities. In addition to the field-based platforms, there are specific experiments planned in controlled environments. These trials will be based at Cranfield University, and specifically the CHAP Agritech Innovation Centre at Cranfield. This CHAP Centre specialises in characterising crop traits or crop phenotyping and also soil health aspects too. In particular, the experiments at Cranfield CHAP will seek to identify the role of legumes in underpinning mechanisms which determine soil functions. such as that for greenhouse gas production, though also resilience to stresses, including stresses generated due to climate change. Also, we'd anticipate that not all legume varieties offer the same range of benefits or risks. This platform therefore offers the opportunity to better understand crop types and their specific traits. Beyond direct data provision on crop responses and soil responses to different environments, the insights could also inform the breeding of legumes for the future, but also soil management. The trials to be carried out at the CHAP Controlled Environment Facility have still to be discerned exactly. The project partners have some ideas, of course. However, we are keen to be directed by farmers' input, since it's important that the trials provide good quantitative data on the multiple benefits which legumes can provide and which farmers wish to see. And these benefits should extend beyond the accounting which we expect, that is, the accounting of greenhouse gases and fertilizer offset potential, to other provisions which a legume-based cropping system may provide, such as crop multiple stress tolerance, which helps buffer production against the impacts of climate change, or perhaps a nature-based solution for crop protection, or to enhance biodiversity both above and below ground. We will be giving special attention to examining the potential of legume-based crop rotations to help buffer the stochastic weather effects which result from the impacts of climate change. Here, soils from the experimental field platform, the Centre for Sustainable Cropping, or CSC, will be transferred to Cranfield's CHAP facility. In this way, the responses of soil from different types of crop system can be assessed in a simulated crop rotation and in response to isolated single stresses and also stresses applied in combination. A full socio-economic assessment will also be carried out by the Anderson Centre. This will elaborate on the impacts of shifting production and consumption patterns towards greater inclusion of homegrown pulses. Also, this assessment will be made across scales to discern impacts and opportunities of local, regional and national economies. The cross-cutting nature of such an assessment is critical, since the impact of and for such upscaling at point of production should be allied to the needs of other value chain sectors. Such insights should help identify where capacities will need developed, such as for crop protection and/or for crop processing. The cascading effects of any costs and benefits also need accounted. As such, an overall synthesis of the data and insights will also help discern the potential of homegrown pulses for national revenues, national greenhouse inventory, plus other aspects of environmental and public health. Thank you for your interest in the NCS project and for listening to this short presentation, and I'm sorry that I could not be with you in person today. Nevertheless, if you have any queries or comments, please leave these with Boffin, who will feed these back to me. Alternatively, here's my email and you may contact me directly. And should you be interested, I'm happy to provide a PDF copy of this short presentation, since the orange text on many of the resources discussed denotes a hyperlink to further information.